Okay, now that we have the terms under our belts, let's take a look at some questions about those terms, and hopefully that will help you to clarify those a little bit more. The first one is asking us to find X intercepts. So I'm going to zoom in very close here, and the arrows are pointing to those because this is taken from your textbook. So they're giving me a hint about where those are. There is one here, and then there's one here. So if you want to go ahead and mark those in there, I think I'm going to disappear all that, or erase all of that green stuff and just use red points right here. So we can see them, but we need to find the coordinates of those points. So this one is at 2 and 0, so it's over 2, rise 0. And then this one is at -2, rise 0. The x-intercepts, remember, are just the x coordinates of this point. So we would say that the x-intercepts are 2 and -2. It crosses the x-axis at 2 points. On this one, you see that this parabola does not touch the x-axis at all. So there are no x-intercepts. We would not want to say 0 because that would make it sound like it crossed at 0. This is no x-intercepts. It does not touch the x-axis. It's below the x-axis. Okay, down here they want us to find the y-intercepts of this first one is the same graph. So we're looking at this point. Where does the graph touch the y-axis? And this is at 0 run, and we had to go 1, 2, 3, 4 below the x-axis. So we would say that this intercept is at -4. And then on this one, where does it touch the y-axis? It doesn't. It doesn't touch this y line at all. So we would say that there is no y-intercept. Okay, and that's all we had to do. If you can see the graph, you can find those much more easily than the points. I'm sorry, I'm trying to answer a text message in it. There is a reason that I don't like cell phones in class. And mine is driving me crazy. Okay, moving on here. Let's do for which value of x is the graph in the positive interval and in the negative interval. So remember, the positive interval is where the graph is above the x-axis, and the negative interval is where the graph is below the x-axis. And this is actually a very pretty picture of the one I used in the glossary. My drawing was not so good, but this is a much better image. So the first thing we want to do is to mark off the points. So here are the x-intercepts at +2 and at -2. Okay, so anything in the yellow is going to be in the positive interval, and this is where the graph, remember here is let me draw a vertical line through those. This may help too. So if you put those vertical lines in there at the intercepts, this will help you see those intervals a little bit better. You see that after we get to 2 and it keeps climbing, it's in the positive, or it's in the positive over here, but it's in the negative down here. So that's what those intervals are talking about. The positive intervals are when the x's have passed positive 2 or when they drop below negative 2. So the interval would be both of those together. The negative interval is when it's below the x-axis. So it's between those two values. So you can say that x is less than positive 2 but greater than negative 2. And again, I know that's a little bit tricky to see, so don't sweat that one. It's not that big of a deal. All right, for which value of x is the graph in the positive interval and in the negative interval? Well, if we look at this graph, something very interesting is happening here. Remember, intervals refer to the position in relation to the x-axis. So if you color code that x-axis, everything is above the x-axis. So the positive interval, it's always above the x-axis. So they would all be positive and there would be no negative values. There are none below the x-axis. And this is all above the x-axis. They're just trying to focus our attention on where that graph is crossing these axes. For which value of x is the graph in the positive interval and in the negative interval? Well, again, if you look at the x-axis, we have none in the positive because none of them are above the positive x or above the x-axis, and negative, they're all below the x-axis. So we would say that all of them are below the x-axis. Okay. Then on page 26, we don't have to do anything here. We're just looking at their picture. For which values of x is the graph in the decreasing interval? So again, let me put in very clearly that y-axis so we can see. And on the left side of that y-axis, it's decreasing. Let me use my laser pointer to show you. You see how it's coming down on the left side? And then when it makes the turn at that minimum point, it starts climbing on the right side. So we would say that the decreasing interval is everything less than 0, and the increasing interval is everything above 0 or to the right of the x-axis. Alright, for which values of x is the graph in the decreasing interval? So remember, moving left to right, there is no decreasing interval. At no point is it decreasing. It is always increasing because it just doesn't fall. It is a continuous increase from left to right. For which values of x is the graph in the decreasing interval? Well, it has a negative slope, which means it's always decreasing. It's always falling if it has a negative slope. At no point does this graph turn and start climbing. Okay. Name the relative minimums and maximums for the graph. Now, this graph is extremely hard for me to see. I should have done this in color, I think, but let me highlight the graph itself, and you might want to do this too so you can see exactly where this thing is going. It's something like that. So here is a maximum, there is a minimum, there's a maximum and a minimum, and so we're supposed to name those points. So let me get the maximums first. And it already told us, but let me just go ahead. I like to use the actual point. The maximum, let's start with this one right here. Okay, it is back 8 and up 2. And then I have another maximum right there. That is back 2 and up 8. And remember, maximum deals with highs and lows. It's particular highs. That is a y function. So you're going to use a 2 and an 8. Those are the maximums. Okay, the minimums, those are the low points. And those are occurring down here at, if you do the whole point, you have back 4 and down 4. And then you have over 4 and down 4. I'm sorry, I can't read. How about down 6? And again, those refer to highs and lows, so you're dealing with the y coordinate part. Those are at -4 and -6. Minimums and maximums. Okay, number 10 wants us to describe the end behavior of the graph. So if you look at this one, I think the biggest thing that I want you to notice here is that the ends of this graph are not the same. Okay, so we could say that each end is different. You've got on the left side, you've got that end down in negative territory, down in quadrant 3, and then on the other side you have an end that is up here in quadrant 1. That's because this line has a positive slope, so that each of the ends is different. Now if you compare that, and I hope I've given you, I did not, so let me draw you, or maybe I did. Yeah, here we go. Okay, again, this end behavior, you look at this end, which is down in quadrant 4, and this one is in quadrant 2. So we would say that the end behavior is different. Each side has a different behavior. Okay, let's look at this one. So here's one end, and here's the other end. Now definitely we have a line of symmetry there, but both ends are doing what? They're rising. So with a parabola, the end behavior will be the same on both sides. Even though this one is in quadrant 1 and this one is in quadrant 2, they're rising, and they're rising together. And I'll be honest with you, when I was in school, we didn't worry about end behavior. It was sort of a given. So I'm not really sure what they're getting at in this book, but since it's in here, I wanted to be able to show it to you. This one again is a parabola, so the end behavior is the same. Both ends are falling together. So they're wanting us to focus on the ends of these graphs and what's happening on the ends. Okay, this next one is a little different, and there's nothing to do here. I just left the description in there. It says to describe the end behavior. Well, this one approaches the x-axis but never touches it. Again, this one is approaching the x-axis but never touches. It never intercepts the x-axis. So that's a different kind of graph with very different end behavior. This one wants me to mark the line of symmetry. So if I were to put a mirror into this picture, where would that mirror be? And it would be right here. Okay, that line of symmetry right there is where the mirror would sit, because the graph is divided in half. You've got the negative interval on one side, the positive interval on the other side, and the line of symmetry is that green y-axis. So we would say that this is symmetrical about the y-axis. That is where the line of symmetry is. Okay, this one, if you mark the line of symmetry, it's right here. And the graph is symmetrical. Here it's rising and here it's falling, but it is symmetrical about that green line. And that green line is where x is 5. It is 5 to the right of the y-axis. In other words, it's 1, 2, 3, 4, 5 from the y. So lines of symmetry can occur anywhere. Doesn't have to be an axis. It can be any straight line. This is a graph that has rotational symmetry. If you think of that video where the guy kept turning the shape, it would eventually turn around onto itself if you rotate it about this point. So if you could spin that thing and make it just keep turning, eventually it would come back to rest on itself. That's called rotational symmetry. This graph has no symmetry. It's just all over the place. There is not a line that I could draw that would do a mirror image. So some graphs have no symmetry. And then this graph is one of those periodic graphs where you have that repetition over and over and over, kind of like a heart rhythm or the waves in the ocean. Okay, I believe, yes, that illustrated all the terms. So I'm going to stop this video. It won't get so long that way. And then when we come back, we'll look at how to draw some graphs. So I'll see you soon.